already. All on time. I don't know how that's happening here. It's remarkable. So welcome to the first lecture in our fall Cullinan series, Relevance. After this evening's lecture by artist Sarah Oppenheimer, the series will continue through the fall with a talk by the Italian architect and urban designer Alessandra Cinquetta, the Spanish architect Juan Herreros, and the British architect and critic Sam Jacob. I'd like to remind you all that Sarah's visit continues tomorrow with a lunchtime roundtable conversation, which will be kicked off by a response by Assistant Professor Jesus Vassallo. So lunch tomorrow, you're all welcome. All right, so why is relevance worth considering today, and why are these four speakers relevant to this topic? In a world of excessive access to opinions, to options, to information, and to experience, separating the relevant from the irrelevant is ever more challenging. On the one hand, everything seems relevant to architecture. As a generalist discipline par excellence, architecture affects and is affected by everything and anything. On the other hand, we struggle as a discipline and as a profession to sustain a relevant discourse. Criticism has been reduced to likes, thumbs up, or thumbs down. In our accelerated environment, any pause to consider makes us anxious. Claiming relevance renders us vulnerable. Who decides what's relevant? In the school, we, the royal we means the faculty, decide what topics are relevant enough to be taught by us to you. We base those decisions on what we think is important, what we're researching, and what we're required to teach by the NAAB accreditation criteria. You, as students, decide as you choose your courses what topics you think are relevant to you, how you want to advance your own trajectories. That decision requires a degree of self-awareness, which I'd argue you better damn well have if you're going to be in this field. Who decides what's relevant in the world beyond the school? I wish that I could say that architecture critics do, but without a Herbert Mouchamp or an Ada Louise Huxtable, we don't have an obvious voice today that guides architectural discourse. That's why it's critical for you, as a generation, to figure out what you find relevant, and then to articulate and construct that relevance. These four speakers this term were deliberately selected to help incite that discussion. All four are notable because they have very clear projects, and they're particularly good at articulating why they find their projects relevant. But why Sarah Oppenheimer? I mean, isn't she a little bit the odd one out in this group? She's an artist, after all, and how would that really make her relevant to us and our work? For one, as I've argued before, architecture is a generalist discipline. We sponge from everyone and everywhere, absorbing all that we deem relevant. And second, Sarah's relevance is indisputable. We could look to outside authorities. She's a past recipient of such prestigious awards as a Guggenheim Fellowship, an American Academy in Rome Fellowship, and she's exhibited all over the world. But I'd argue that you should look at her work through your own lens to determine its relevance. We all had that chance to do that with Sarah's work in 2010. Sarah came to Rice that summer to construct her installation D17 for the Rice Gallery. Any of you who remember that installation know that it pierced through the gallery's two walls. It was just amazing. And I want to acknowledge Rice Gallery Director Kim Davenport, who's here, I believe. Kim? Wave your hand wildly. There you are. All right, Kim's way in the back. For her smarts in inviting Sarah here and making that installation possible. All of Sarah's work engages space and perception, both of which are pretty fluid and fuzzy territories. But Sarah zeroes in on both with the utmost precision, constructing forms that have only a 1/32 inch tolerance. Her construction of these forms uses design methodologies, technologies, and representational techniques from which we can all learn, not to mention that she ultimately creates an architecture of space where walls once had been, literally opening up possibilities for architecture, art, and the perceiving subject. I want to welcome Sarah here. I'm very grateful that she's here for the Cullinan seminar, and I'm looking forward to her talk. Thank you for coming.
Okay, it seems to be on. Hello. First, I want to say that I am extraordinarily happy to be here. It's a very unique experience for me to come back somewhere. And first and foremost, Sarah, thank you for inviting me, and thank you for opening up the possibility of this conversation. Something that I really find also very unique about this particular opportunity is that it's very rare that when you go somewhere to actually have a dialogue with those people you are addressing. And I really appreciate the possibility of speaking with you and hearing what you think, potentially about the questions I pose, but also potentially about the questions that you are posing in your own projects. So I very much look forward to extending that in the next couple days. And lastly, and of great importance, is the fact that this university, in particular the Rice Gallery, has been very, very, very formative in my thinking about how my work may address very particular problems. And what I'd like to do is frame those problems, but I'd also like to point out that it's interesting, you'll find through the course of your own work, I'm sure, that the questions arise as a kind of, as a surprise in some ways, and that questions open up and expand over time. So I'd like to say a huge thank you at the outset to Kim Davenport and to Josh Fisher, who are both here tonight, in that you have opened up a huge range of questions for me in the development of my work and in the development of, I imagine, the questions that my work will grapple with for the next 25 years. So with that in mind, I'd like to begin talking about what is in front of you. I think this is a laser pointer. Let's see if I can make it happen. All right. So what you see here is you see a line. And that line in this particular slide is a white line on a black background, or in fact it is a light surface on a darker surface. But what I'd like to do is I'd like to think of this line as a boundary between one side of this wall and the other side of the wall. And I'd like to think about how this boundary, in fact, seems to be impossibly thin. It occupies no space. I'd like to start thinking about how this boundary might, in fact, let's see if we can move forward. Get thicker. And that thickness actually is not an arbitrary thickness or simply a wider line, but in fact suggests the possibility of a location that we actually don't perceive, because it is buried between here and there, or inside and outside, or me and you. I want to think about that location as a possible site for work. And I also want to think about that location as a materially changing location. It could be, for existence, constructed of something as simple as my shirt. It could be constructed of something as simple as sheetrock, glass, dirt. Its materiality is in some ways up for grabs. But most importantly, I want to think of it as having a materiality and having a kind of very, very important present thickness. This boundary space exists between a series of zones. It could exist between two zones. I like to think of these zones as perhaps interchangeable, and for that reason I start to think of them as generic, or having a kind of interchangeable condition where you have an A zone and a boundary between an A zone and a B zone. Or it could become a more complex arrangement where you have an A zone adjacent to a B zone that is floating over a C zone. Or you could have a condition where you have four discrete zones that are in fact divided by two boundary spaces. Obviously, the arrangement of these boundary spaces is complex. But in considering this arrangement, I like to think of it as evolving out of what I term as an array. I will now describe specifically what I'm referring to. The array. 1. Space is divided. 2. Spatial boundaries result from conventions of architectural and urban context. For example, materials and dimensions of interior space are prescribed by industrial relations and code requirements. Such contextual determinants create uniformity in the division of space. Public courtyards, corporate lobbies, hallways, rooms, etc. This regular division is the array. 3. The array goes largely unnoticed. Much like user-friendly software, its ubiquity naturalizes the dynamics of spatial division. The array constitutes a spatial authority, creating conditions that invite rupture within the patterned progression of space. 4. Habitation of the array is time-based, a flow embodied by a moving, active stereoscopic agent. Inhabitants experience the array over a period of time. 5. Memory knits the temporal chain into a cogent spatial map. Perceived conflict within this mnemonic map heightens the experience of spatial discontinuity. I would like to point out something very specific in these A, B, C, D arrays, or diagrams that you see in front of you, which is precisely where they may perform as a kind of spatial anomaly. Here, let's see, we have a single boundary space. We could say an A-B condition. Here, an A-B-C condition. And here, an A-B-C-D condition. In fact, we could say all three of these are A-B-C-D conditions, but with very different set of potentials. So, for example, here, this zone on the upper right and on the lower left have a shared surface, but these two zones do not share any surface whatsoever. However, if you inhabited those spaces, if you were existing inside of those spaces, you would not perceive any difference between this array and this array, where in this case, unlike in this quadrant or ABCD condition, where you have a kind of thick corner, here you have an impossible corner, where in fact there is zero material dividing space A and space D, even if you perceive them as utterly separate. But the division of space is not only defined by the location of physical boundaries. It is better understood as discrete zones, defined by a set of relations. Here, for example, we can understand the boundary between two spaces is defined by the limits of the visible from any single location. So, for example, if we imagine this as the position of a viewer, and this series of rays projecting out from this point as all visible space from that specific position, we here see this large white square as creating a set of occluding zones that pass behind or obstruct the 360-degree view from that single position in space. Urban planners have long been interested in the sightlines available within the urban context. In the 60s and 70s, planners developed a diagrammatic tool named Isopist. The tool describes the field of surrounding space visible from any given point, assuming 360-degree vision from a single point. Here, the isomist is articulated by a two-dimensional array equally determined by the position of viewing and the occluding contours of the white square. As Julian Rose indicates, the concept is extremely useful in understanding how new development in a downtown might affect the visibility of an existing landmark building, or how much of a park can be taken in from a particular spot within its terrain. As the viewer moves through the space, you'll notice that the occluding edges change on the given volume. My interest in the possibility of understanding perception and spatial navigation has expanded over the years, but it began with a virtual reality experiment developed by Dr. William Warren. This experiment explores the relationship between visual field cues and a mnemonic map. The virtual world of this experiment is a complex topiary maze, and test subjects are asked to navigate from here to there or from one landmark to another landmark. At certain junctures, there are holes in the plan, not dissimilar to those holes one finds in Pac-Man, where, for example, you are moving through as a kind of munching animal, and you exit field left, but find yourself dumped through an impossible circulation field right. Importantly, it's much easier to understand this relocation of the body or self or subject when looking at something in a plan view than, for example, when playing a game like Portal, where you find yourself submerged within the perspective field of the game and thereby unable to differentiate where here is in relation to there. An early piece that played with this possibility was a piece that was developed in 2008 at the Mattress Factory. And the project used William Warren's dynamic or idea of what he termed the wormhole as a way of thinking about spatial navigation. So to simplify this conversation, let's say you are starting in this box here, and you are walking from this point around this long distance to this point down here. Well, because it takes a certain duration to move from point A to point B, you imagine there's a certain distance that your body has to travel and a certain distance between the 2 points. But if you create a kind of visual shortcut from point A to point B, you suddenly have a collapse of these relationships, where these things start to coexist in the same field. This becomes ever more disorienting, or more complex, perhaps, when we start thinking about the relationship from what is above us to what is below. Here we have an image of the work. When you enter the space, you see the piece embedded in the floor. And when you get closer to the piece, you start to actually feel the air that is coming from the exterior entering into the space. And the sound of the piece is also, the sound from the exterior of the building is heightened as you get closer to the artwork. This is a view of the same work from the 3rd floor of the building. And this is a view of the work from the building exterior. I became increasingly interested in the possibility of seeing multiple places on the same plane, or understanding the boundary as the kind of carrier for multiple views at a simultaneous moment. And early explorations into this problem involved a very simple exploration into the thickness of the single boundary plane. Here we have an A-B condition, A and B. And we have an opening within the thickness of this boundary wall. The opening is lined with a reflective surface on the top and a reflective surface on the bottom. And there is a direct sight line from eye level on one side to eye level on the opposite side of the same wall. However, there is also a reflected sight line from these 2 positions, where standing at eye level, you will see an inversion, meaning what is above is now seen below, and what is below is seen above from the opposite side of the same wall surface. The striking thing about this condition is that the distance of the viewer from that wall surface causes a perceptual change. So when you're standing a certain distance away from that wall plane, you actually perceive these two as the 2 images as identical or very similar to one another. They become equivalent. This is the direct view through, and this is the reflected view from this particular vantage point. But as either you, the viewer, or the object you are viewing, meaning the bodies on the far side of the wall, get closer to the boundary plane, the inversion becomes more apparent. So here you see the upper body below the lower body. And this is the work from the opposite side. The AB condition can be expanded, or perhaps we could think of this thickness as now becoming a kind of inhabitable space, so that rather than simply looking through or across this border plane, one can now reside within it. Here we have a project where that AB condition is transformed into an ABC condition, where now a viewer stands on one side of the boundary and on a far side of the boundary and gazes through the floor plane of a small room above, or the viewer stands and looks through reflected, across two reflected surfaces into the small space above. Here we have the entry into the upper room, and here we have the front wall surface. Here we have the upper space, space C, looking out over a field of white walls. And here we have the view from the ground plane, where you are standing in the space looking through the floor plane of the people above, and here you are seeing the people standing in the space above. Over time, I began to wonder how this particular or obvious vertical plane could in fact simultaneously operate as a horizontal plane. It could function simultaneously as a wall, as a ceiling, and as a floor. This possibility became interesting in part because of how it intersected the sight line of the viewer. So as one moves around it, the thicker sloped plane starts to create a series of dynamics that are far more likely to change as the body moves. The intersection of these sloped planes creates a very specific geometry. In this particular project, the edge of the piece seems impossibly thin, and as you encounter it, you walk below it. And you then stand beneath it and look through the thickness of that plane out into a space beyond. And something that is very present in this work, or was very present in this work, but is not apparent from these photographs, but has become very important in later works, which I will discuss, is that actually there is a very specific light change that's occurring here that is altered by the way these photographs are taken, which is this: these photographs were taken using strobes, which causes a very cool light to kind of diffuse across all of the surfaces. But there is also a very cool light coming from the exterior. And that cool light is somehow reduced, or the contrast between the warm and cool is reduced because of the light of that photograph. But I'd like to return to the problem of the isovist, because in many ways, and this came up earlier today in the Brocken talk, in many ways the possibility of using the idea of a moving viewer as a kind of core form of investigation has become increasingly central in how these projects have evolved. What you see here is a space that was initially I was invited to do a project initially for this space that had 5 discrete zones. It was an A, B, C, D, E location. And in thinking this through, I wanted to develop this problem of the isovist as a way or a tool for thinking about how one might navigate these locations. I wanted to understand the isovist as a volumetric form. Working in collaboration with a programmer, I developed a custom script for our digital software. And I'd like to say a little bit now about the use of scripting in the studio. The scripting is central to the procedural logic of the work. All digital models are clusters of numerical coordinates within a Cartesian matrix. Parametric scripting assigns relative value to these coordinates, creating a set of interdependent variables. For example, variable A, the height of an object, can be scripted to be dependent on variable B, the width of an object. Any modification of the height will automatically modify the width. This principle can be applied to any numeric value within the system. So, for example, the location of a light source can be dependent on the time of day, or as in the case of the isovist, the volume of the isovist is dependent on the relationship between the total architectural volume and the position of the viewer. The software automatically updates the isovist in real time as a point is moved around the space. Here is an example of how that works. So, for example, in this very simple model, we have a fully enclosed volume where a single point represents the point of the viewer. If you input that point into the model, you then can actually see or generate the isovist from that given point, and also then observe that volumetric space. And as you move that viewer around within your model space, you can start to perceive how that, in fact, might change, that isovist volume would change as the viewer proceeds through the location. The possibility of encoding perceptual cues within a parametric model recalls debates in contemporary art extending from the late 1960s to today. In 1968, two significant exhibitions, one at the Stedelijk in Amsterdam and the second at Kunsthal Bern, argued for the centrality of sight in shaping a work's form. Describing the work in Oplossschroeven at the Stedelijk, curator Wim Bering argues that the work has changed from, quote, an artwork that dominates and determines the space to an art that takes up a certain relationship to the space, end quote. The shape and form of the works in the exhibition were dependent on context. When works were reinstalled in a new location, the form of the work was altered. Sight was a non-transferable, specific set of sensible conditions that shapes an artwork's form. Scripting universalizes these sensible conditions, assigning numerical value to a location's changing qualities. Properties of sunlight, moisture, condensation, temperature, vibration, reflection, etc. are transformed from sensible affect to quantifiable variable. This transformation actively argues against the ongoing presumption that sensibility of sight can unmoor the artwork from predictable arrangement. The isovist was used as a way of starting to think about how to contend with the irregularity of this location. In particular, a major challenge to the construction of, or the stability of the form of the isovist as the viewer moves through the space was this column right here. The resolution of this irregularity came in the form of extending the grid so that the columns, in fact, were buried within the walls or within a single new wall, and a new zone was generated. So now we have an A, B, C, D, E, F zone, and the columns, you'll notice, are located not where one might expect them, which is in the intersection of this of these two walls, but in fact off-center, so that the opening, or so that the corner spaces, were in fact not filled with structural material. This meant that those corners could be excavated or opened up, and that the opening of those corners would create a kind of irregular void space. It also became very important to understand these zones not purely in terms of what is visible and what is not visible, or let's say the possibility of the occluding edge, but also in terms of zones of light and dark, or the color or temperature of white light. Here we have a similar diagrammatic form representing something quite different, which is we have a light source and we have a figure. And the figure, as they walk from the illuminated zone across the boundary of illumination to a darker zone, experiences a very specific perceptual shift. And in thinking about that shift, I wanted to be able to model that condition. This led to a series of light studies, and the light studies, I think, were very, very interesting. And they also raised all sorts of very complicated issues about scale, which I think came up earlier today in our conversation. One very striking aspect of the light studies was that light is a kind of a beautiful scalar condition, meaning that you can experience light on every scale. Well, the way we did this was we created a physical model, and then we added a series of fluorescent bulbs that all had the same Kelvin value, were made by the same manufacturer, and were running off the same system. We then used a series of theatrical lighting gels, which allowed for a kind of translation of the Kelvin value of the bulb to any other Kelvin value of the bulb within the spectrum of white light. And we used a very simple translation system, which here you can see is a product of Lee filters, which allows you to say, okay, my original light source is starting at 3000 Kelvin. And if I use gel number 205, I can translate what is a relatively warm condition to a warm condition, or what is a warm condition to a much colder condition. In order to study the models, or the changing warm and cool white light as it passed across this model space, we did a series of tests. And the tests required not a Rhino-based model or a render engine model, but it required an actual physical light condition where the Kelvin values were set up in various ways. So here we have these different gels along an A, B, C, D, E, F space. And here we have a series of models where you can see we were basically moving gels around and thinking about how different warm and cool light shifts, white light shifts, might have a resonant effect. This is a photograph of that model. The other important development through this process was the development of the specific connection and thickness of the material. So one very critical aspect was how to create a surface that basically lined the incision across the thickness of the material that was not seamless, but it actually articulated the seam, but created and maintained the collapse or the absorption of light so that when perceived from a distance, it would appear incredibly flat. There would be a great reduction of depth perception. So we developed a script that allowed for basically a joint that was based on a wood flat joint. And that script started as a series of possible joint sketches, and then led to a basic parametric model that allowed for a series of variables which determine this joint system. So here we have the length of that joint. It was basically a lap joint, which was involving a flip mill. The frequency of the lap joint. The tolerance between them across the folds in the material. The size of the router bit. And ultimately, the beauty of the system was that we could test for material intersections prior to milling the material by looking at how these materials actually develop themselves as three-dimensional form. This meant that in a series of projects, this joint could be used and also could be modified without any great degree of attention or detail. This is a sample of this early version of this material. And this is another sample using the same definition. And this is a three-way joint where we have specifically a bent piece of material and an elongated tooth or lap joint across that material, creating a three-way intersection. And this is the location of that detail in the larger project. This is the ABCD condition. You enter the space from this particular room, and what appears to be quite blue in this room and yellow in this room is actually not blue or yellow. The way the photograph was structured was that the neutral grade was set in each of these photographs that you'll see to the room in which the photograph was taken. So everything is a kind of relative warmth or coolness. This blue color is daylight. This warm color, I believe, is 4100 K. You enter the space, you walk through this threshold here, looking into a storage room which has a 6,000 Kelvin value fluorescent bulb into this space to the right. You look back out the window in the far space beyond. You round the corner into a double and see the two apertures simultaneously. There's a joint right here. There's another joint down here, a bit hard to perceive because of the viewing distance and because of the tonal contrast. And here you're standing in the daylit room looking back into a fluorescent lit room, which is not actually a deep yellow, but appears yellow when you key the photograph to a color neutral. The other thing that became very important as a result of this project was the relationship here of this large plane of glass to the floor, and specifically the fact that the glass floated above the floor plane and created a kind of tension between this edge and the ground plane. The next project I'm going to talk about is a project that was begun, and actually I think in certain ways the ways it begun have become more resonant to me. It began through an invitation to create some sort of piece of work that in a large atrium, an empty atrium space, which of course no space is empty, but a space that seemed to require some degree of filling. In this location, this kind of wedge space was a boundary space between what was a contemporary this is a diagram of the Baltimore Museum of Art. They had a contemporary art wing on this side, and on this side of this wedge, they had a kind of modern collection. We can think of these as two discrete zones with a kind of neutral or thick wedge space between them. Or we could think of the sides of the wedge as having a kind of thickness unto themselves. And ultimately, that was the direction of the project. So I'd like to talk a bit about this thickness right here. And I would like to talk about this thickness as a section running through it. So when you look at the section, this was the space as it was originally presented. You had a large, allegedly empty atrium space. It was actually filled by a Henry Moore that was sitting right about here. And you had a landing space. So as you walked up this circular stair, you'd reach this landing, which was a kind of half floor. And then you'd continue up this floor here and enter the gallery space beyond. So this is that landing space. This is the contemporary gallery. This is the large atrium space. And this is the upper galleries of the contemporary wing. The project basically took that array and made some minor alterations. We cut a hole through the slab of that upper floor. And we also made this wall much thicker, which allowed a whole host of things to occur. Most importantly, it allowed a change of sightlines across that boundary plane. In developing this work, a series of studies were done on the possibility of viewing across a reflective surface within the thickness of this wall and down through to the floor below. And what you have here is a very simple diagram showing one of the great challenges of this work. So everything, all of these figures in red, all the sightlines in red, are viewing an obstruction. And specifically what's happening is as they look at this mirror plane, all of the sight lines are not actually passing through the hole in the slab, but because of the depth of that slab, they're actually intersecting with the walls or the thickness of the slab itself. So there's a lot of reflection of the actual structure itself. And this was not only true from these upper galleries, but it was actually true from every viewing position. So as one ascended these stairs or descended these stairs, when looking at a reflective surface, the sight lines would constantly intersect with the walls of the aperture or the walls of the incision in the slab or wall itself. So to deal with this, we developed a kind of more complex isovist. And this isovist allowed us to think about how reflection might in fact change the geometry of the field of vision. Here we have a very simple diagram of that, where this, I'll just explain this slide for a moment. This orange piece down here is the slab surface. These are two primary beams. There's also kind of ghost of beams that we added to the slab to reinforce around this opening. And this is this kind of strange, funny shape that looks like a face or a head. That orange shape is the shape of the skin, the aluminum skin that was actually inserted inside of the wall system. And this yellow shape is a reflection of the orange skin across this 45-degree mirror surface. And the reason that was important was we needed to start to understand how self-reflection worked, how looking across that mirror one would actually start to perceive the boundary of itself. And what it meant was that we could actually choreograph the self-reflection into part of the work. So here we have an encounter with the piece itself. As you enter from the second floor, you'll notice you walk across it and there is a kind of monochromatic condition where you have all blackness throughout the entire aperture. And as you move across the surface, this upper quadrant remains black, but the lower quadrant reads as dark blue, And the reason for that is that, like the other photos, this photograph is keyed neutral to the room that it was taken in. But the blue is actually daylight from the atrium space beyond. As you continue to move across the surface, you start to see this yellow trapezoid appear far right. And as you continue, it starts to become a kind of simple grid structure where you have a yellow and a blue trapezoid and two black trapezoids. Now, importantly, the upper quadrant is entirely a reflection, which means, just to back up one, this is a self-reflection, and this is a reflection through the artwork. And what's actually being viewed in the reflected surface is the view through the artwork to the floor below. Here you can see the teeth, or the joint system. It's a very different geometry than the joint system in the previous work, but it's entirely the same parametric system that has generated it. And here you can see it in a non-reflected surface, so it's actually very big. This is a view of the work from the lower level of the contemporary wing. And this is a view of the work directly into the opening, and of a viewer from the upper floor looking down to the lower floor. But this brings me back to Rice. And the reason it brings me back to Rice was that at some point, I started to recognize the problem of this impossibly thick condition. What does it mean to locate one's work in the impossibly thick pochette of a building structure or an architectural structure when so many architectural structures are dealing with a very different kind of boundary condition, which is a boundary condition that is, at least in its aspiration, impossibly thin. And I would say not only impossibly thin, but is also impossibly transparent. And I think that my encounter with the Rice Art Gallery really called my attention to this problem, because it suddenly became apparent that that thickness, which could do so much to erase the footprint of the artwork, in fact, at the same time, was in some way a lie, or it didn't speak to a very contemporary condition of the building envelope. So for those of you that are students here or faculty here, I'm sure you're very familiar with the Rice Art Gallery. And this project that was completed in 2010, 2 years before the two projects I just showed, was my first attempt to deal with this glass barrier. And I was very interested in thinking about how this glass wall could in fact create a kind of transmission and how you could articulate an opening from one zone to another zone. But in hindsight, in thinking through how this actually operated, I became very interested in a very specific condition that was a property of the glass wall itself. And that condition had to do with the simultaneous transparency and reflectivity of that material. So that while looking at the work, at once you were looking through the glass at the work, but you were also looking at yourself looking at the work. And that glass plane became a projected surface on which one could see both here and there simultaneously. With this in mind, I decided I would try to simplify these terms and think about them in a much reduced state. Rather than as an ABC condition, as was the case in Rice Gallery, where you had a gallery space, a foyer space, and an exterior, I wanted simply to think of an AB condition, where you had a very simple interior, two interior spaces divided by a single wall. Initially, this wall was a thick, opaque surface, and an opening was cut out of that surface to create a kind of window space. But instead of having this window space be simply empty or open, I started to think about how we could have this double image projected on a single piece of material, or in this case, a single piece of glass. And I use the thickness, or the idea of self-reflection, as a way of calibrating this. So what you'll notice here is you'll have, this is a view of an AB condition, an aerial view. This is looking down on an individual, looking at this semi-reflected or coated piece of glass from one side. And the sides of this aperture now are lined with a black material, in this case an anodized aluminum that's directionally sanded. So if you are looking at this coated piece of glass from one side, and it has a black surface behind it, you actually have a reflection because there's black behind this piece of glass. But assuming the light levels on both sides of this boundary plane are equal, when you're standing on this side of the glass looking through the, or across this glass plane to side B, the glass becomes transparent. You can see through it. But there's a very specific location in this glass where you have, when backed by black, when looking at it from a single position, you see through it, it becomes a reflection, but what's reflected is a self-reflection, which creates a kind of stable bar across the surface of the glass as you move around it. So here is an image of this situation. When looked at from the side, it becomes an open, transparent piece of glass. But as you move across the glass, you start to notice that, in fact, this line is actually a self-reflection. You're looking at this piece of glass, and you're actually seeing this inner surface of this side of the wall reflected on it, which keeps this bar stable as you move around the work. This very simple principle, which I would say began here at Rice with the challenge of that large glass wall, was extended to a project that actually had a slightly more complex arrangement of zones. Here we have an institution where it was an old factory building, which had two very different building grids. And this is the final project I'm going to discuss this evening. One building grid is running on a 45-degree to the other. And when extending the grids across the building, you start to see a series of intersecting zones. The additional aspect of this particular space that I was asked to respond to, which is this long extending gallery, is that it had a series of windows on one side of the space. So as you walk down it, you had a sense of it being extraordinarily sided. Light was constantly pouring in from one side. In thinking through the problem, I started to think how one could extend the grid of the building from one aspect of the building into the next aspect of the building, and thereby create a kind of translation or a torquing of these two structural moments on top of each other, and could use this these double grids as a way of transmitting or not transmitting light through this system. The initial study started to look at artificial light. How could we start to play with the possibility of having different layers of reflection or transparency? But it quickly became apparent that it was impossible for the artificial light to compete with the extraordinarily bright daylight that was pouring in from the single side of the building. This obvious condition, where one side of the building was so much brighter than the other, started to play into how these very specific boundary conditions would pick up or transmit this layer of illumination. So here you'll see that each wall, these are opaque surfaces now, have a bright side and a dim side. Bright side is indicated by the large, thick line, and the dim side is indicated by a fine, thinner line running on either side. Intersecting this grid, or actually extending this grid, were two very large pieces of glass, which one of them was here, and one of them was here. And notably, not only did the wall have a brighter side and a dimmer side, but the glass also had a brighter side and a dimmer side. And this led to a very specific visual arrangement. When standing or when entering this gallery space, you looked through the dimmer side of one piece of glass and at the brighter side of the opposite piece of glass, creating transparency through the first glass and reflectivity through the second, and bouncing your view to the outside space beyond. The isovist for this particular condition looked very different than the isovist would have if it had not been a reflective surface, or if the light had been on the opposite side of that same piece of material. So here we have an isovist that's shaped by these opaque walls, passes through transparency, and is bounced off an illuminated surface to the space beyond. And here we have a set of photographs taken from those positions in space. You're looking through this very large piece of glass, which is hovering across the floor plane and is at 90 degrees to this wall here, at another large piece of glass, which is bouncing your view out the windows beyond. When you occupy this central space, you are on the illuminated side of both pieces of glass, because both pieces of glass are angled at 45 degrees to the window. So if you continue looking at the large piece of glass in the back end of this room, what you see is a view to the space outside, and you can then see individuals standing outside, and at the same time, because it is also a transparent or partially transparent material, you can watch the ghost of someone walking through what seems to be a reflective surface. Here you might get a slightly better sense of how this operation is working. Obviously, when you stand at the opposite end, the condition is reversed. So when you're standing at the back of the space, what was previously reflective is now entirely transparent, and what was transparent is now reflective. This is the second isovist study. And this is the view from the far side of the space. So now we are looking through the large glass that was previously reflective. The glass is supported within the thickness of the wall by a kind of clamp. So this is kind of a shark fin-like profile, this piece of glass, and the clamp prevents the glass from pivoting or rotating. And the load of this piece of glass lands on this small plate that is down on the floor. So this is floating off of the ground by about a centimeter. And here, the piece of glass that initially appears transparent becomes reflective. At night, this condition is inverted, and what was reflective becomes transparent. The boundaries delimiting our built environment can be understood as invisible, opaque, and impossibly thin. They could also be understood to embody an incredibly broad and expansive set of questions that engage both the organization of space and the organization of information flow. Contemporary art institutions often rely on archives of digital files, such as construction documents, capacity studies, light and temperature analysis, etc. Computer-aided design allows for this information and proposed alterations to the built environment to be shared between parties without material consequence. The studio's use of Rhino, CAD, scripting, etc., allows for a scalable practice that integrates with these particular contemporary conditions. This integration into conventions of information flow raises a central question regarding the possibilities of institutional friction. Architecture is a determining characteristic of contemporary art. The spaces of exhibition, the logic of their operation, and the iconic public face of the museum increasingly determine forms of new work, often fabricated specifically for display in museum galleries. Light projection and performance are remarkably scalable and adaptable to the architectural envelope, well suited to vast spaces with relatively small budgets. Institutional friction is often minimized and context is erased by live bodies and moving images. The procedural method of digital architecture shares the scalable possibilities of light projection and performance, but it also deviates at key points. By adopting the procedural methods of architecture, an artwork is able to operate within an evolved, pre-existing codified system of information flow and material manipulation. Friction arises precisely at the moment where that the invisible rules underpinning the architectural envelope are questioned. Importantly, this is not limited to the symbolic realm of building code, flow studies, and structural requirements. This symbolic system is materially manifest in the inhabitation of architecture. Spatial reconfiguration has the potential to transform this symbolic exchange into an experiential reality, allowing agents to reconsider their location within the architectural context. Thanks. A what displacement?
Maybe it's about position, but I'm curious if you have a general idea about what the boundary is.
Well, I think the boundary, I think that's a great question. I think that it's a kind of open, it's a question which I don't have a fixed answer to, but it's a question that I'm really interested in. So, and I think there are many ways to think about it. So there are ways to think about it as a kind of social mediator. I've been really most recently I've been very interested in thinking of it as a kind of switch, which allows for transformation within a set of network zones. That also, I'm going to back up when I kind of talk about this, but one of the reasons for my interest in that is I've really noted engagement both in art and in architecture recently in this idea of flow or kind of the immaterial transmission of things such as light and temperature and air pressure, etc. And I always feel that on some level there's a sort of odd fallacy in that, because in order for those things to even be knowable or measurable, there needs to also be a kind of limit to the zone that we're discussing or that's being articulated. And in that sense, I've been interested in thinking of the boundary as a switch, so that it isn't a fixed limit, it's a limit that mediates or modifies transmission. At the same time, I think there are much older ideas around how this boundary operates that I'm equally interested in. So one of the readings that I passed along was Bridge and Door by York Simmel, and thinking about how that boundary is very much a kind of significant maker of conditions of separation of self from larger social structures, and also integration of self into larger social structures.
I wonder if you could talk a little bit about craft and how important it is. I haven't seen some of your pieces in person, and even the images, they're always these beautifully crafted objects. And it seems like is that necessary for the illusory effect, or is there something else going on? I guess, for instance, like, why not black paint instead of these incredibly beautiful dovetail lap joints in the frame, etc.?
I think that's a really good question. And it's a question that I really grappled with. I think that I'm extremely interested in how materials can be manipulated to have a set of properties, and also how materials have properties that are their own already. And one of the questions that came up earlier today, I'm not sure, you said craft, right? Yeah, I'm not sure craft is precisely the term I would use, but I do see that as a question. There was a double condition for me. The first is that I early on became very interested in the depersonalized work, so that it was, I was looking at people like Oppenheimer and the telephone paintings and thinking, how could you think of that information transmission as the qualitative condition of something? So in that sense, the digitized fabrication became very central to removing hand from what you may call craft here. But at the same time, I think the work has retained, at least up until now, a very specific imprint of a material life. And I think that relates to this conversation we were having earlier at the Brocken talk, which was, how is drawing working in this work? And I was saying, well, I use drawing as a way of figuring things out. And one of the things I'm interested in figuring out is how materials work, and what can materials do, and how can materials perform. So part of what you're seeing in what you're calling craft is an exploration into how these materials have the properties they have, and what can they give you.
I wonder if you have kind of a half-formed question, or somebody's question is a request for maybe a elaboration. I wonder if you could discuss the difference in your work between the way you're talking about it as stuff, as material, maybe related to Troy's questions, for instance, and its reception. And I'm aware that maybe the question actually would stand without an answer at all, because I think many people would want to talk about work like this and say, I'm not going to talk about reception, I'm going to put that in your hands as the way that minimalism sort of did that, say. But I'm trying to figure out if that's the case, first of all, or if you would in fact like reception to be along the lines of the way you talk about it, or if you would say that reception should become more like what one would do in front of a minimalist painting that produces a kind of reverie moment, if you see what I mean. So I'm trying to figure out if you would want me to walk up and say, this is a reflective piece of glass surrounded by a piece of extraordinarily beautifully detailed material. Would you like me to see something else? I'm not really looking for instruction. I'm more interested in how you see the relationship between those two.
I think that's a really interesting question. I really have no interest in reverie at all. I have no interest in reverie. I have no interest in people coming to the work as reverie, I think because the work is dealing with things like light temperature, there is a history of art making practice where light temperature invokes a condition of fixed contemplation. I am, however, interested in an acute reconsideration of one's own perceptual field. And I don't think that's the same as reverie. And I think it also requires a kind of slowing down, actually. And I think that slowing down may, in fact, be part of what one might think of as reverie. I'm not sure I'd go there. In some ways, I really don't want to go there. But I see that that is often a kind of collapse.
I have a question that piggybacks on that, actually, because it's interesting to listen to you explain the work, because we get a little glimpse into your obsessions and your sources, which range from modern art to cognitive psychology and incredibly precise material studies, right? And you go through each project, and you're in this little world of, you know, A, B, C, D, change, make one change, and the world changes completely. But what I think is interesting, and this relates, I think, in part to what Ron was asking, is then the end product is not didactic. You're not, your viewer doesn't get that same sort of process discussion that you've given us here, or that same, it's not just process, it's a delight with those many sources and with the play of very objective knowledge and very subjective perceptions. And this sort of wiggle room between that you're constantly dancing in. And so, but I'm surprised that the end product is not so singular, that it opens up so many possibilities. It doesn't reveal, it's not a solution when you see the work. It's sort of even more complex perception. And so it's very different than your lecture, which is, and I'm trying to get my head around those two differences. It's a reception question, reception perception question as well.
Well, it's kind of an interesting thing, I think, that you're posing, because it makes me think of how a lecture might operate differently. So one thing that it makes me think of is Arnheim, and how if you're looking at visual thinking or a number of his texts, there's a diagram in some of the earlier chapters where you'll have a square, right, and you'll have a circle, and the circle will be ever so slightly off center. And the question will be, do you perceive this as balanced? And that's kind of the question. And there is no answer. It's sort of, you look at it and you make a decision. And in some ways, this lecture there's no room for that decision. There's no room for you to make that decision because you're being told what is occurring at every turn. So I think that it opens up a whole other type of engagement of how a lecture could operate. And I think that ultimately that is the question that I throw out both for myself and all of the people I work with. When we make that one tiny little change, we sit there and say, and we don't have an answer.
Nice, or I like this. Yeah.
Right, I like this, or kind of, who knows what. I mean, there's this kind of constant looking at that circle and deciding if that circle should be there or not be there, or if that circle should be there or be 1/32 of an inch over. But it's a good question. I think it's also a kind of pedagogical question.
Yeah, like we're talking about relevance, right? So usually like something is relevant in a relationship of absolute.
How relevant you are.
Yeah. Usually something is relevant in relationship of accomplishing and all when the possibility to accomplish at all. So what is really good is the final objective that actually like allow consider this relevant.
Well, I'm not sure this is relevant. I mean, I actually think to go back to Sarah's comment a moment ago, I think that it's a question. I think that this work poses a question, and its relevance is really not my decision. Although I am entirely engaged in the problem. But if I was going to articulate what the problem is that I'm engaged in, and which in some ways you and the world beyond you determines whether it is relevant or not, and what it is relevant to, I think that that question is really how could one create a hyper incision in our experience of a location such that we start to understand where we are in relation to others, other locations, etc., as a kind of simultaneous condition, not as a time-based condition, but as something that is simultaneous. So we understand what is around us as a extraordinarily collapsed time. And one reason I think this, at least to me, seems extremely prescient is because, or relevant, is because I think that in our navigation of both social space and information exchange, there is this condition where all things are present now. And all views, one of the things we were talking about earlier is we're dealing with these spatial representation softwares where all views are present to us simultaneously. We're dealing with communication software where we're looking at 5 places or 5 people in 5 different countries simultaneously. And that kind of simultaneity spatially is almost always denied. And I'm really interested in how that could actually become a present, tangible condition.
So are you talking about a collapse of space then?
Yes, I'm talking, but a very specific collapse of space. So one of the things that I'm really excited by is sections. And the reason a section is so fascinating is because it's a kind of impossible drawing, right? You can never really see that. You can never really inhabit the section. And in that sense, that is sort of a collapse, but it's not the collapse of a composite. It's a different kind of, it's a very specific type of change or compounding.
All right, the readings that Sarah assigned to the seminar that's interviewing her tomorrow morning are, as a reminder, available on the All School OwlSpace site, so you can dive into Oppenheimer 1 and Oppenheimer 2, which were resources behind Search for Thinking. But we will convene again at lunchtime tomorrow, starting with Jesus being put on the spot, and then the rest of us have a chance to ask more questions after we've had time to either have sweet dreams or nightmares based on A, B, C, D, and E. Thank you.